Okay, so related rates. Rates are what it says here, quantity over time. Quantity over time, amount of anything over time. It could be distance, it could be anything. It's just over a set period of time. And because of that, it's a derivative, right? A derivative is a rate. Slope is a rate, right? Slope is y over x, right? Y is the quantity, x is the time. So when we're talking about rates, it's always with respect to time, because time, it's always over time. So change occurs over time. When we talk about how a quantity changes, we are talking about the derivative of that quantity. Okay? So when we, again, right there, that's the key idea to related rates. When we are talking about when we're talking about how a derivative change or a quantity changes over time, anything changes over time, we're talking about a derivative. Okay, we're talking about a derivative. And that derivative is always with respect to time. So it's not with respect to x. More specifically, it's with respect to time. Okay? So that way, so any rate, we can state this mathematically as d quantity over dt. So the first rate, Marty is growing at a rate of 3 inches per year. Okay, so what we have to do is fill this in. We know it's over time because it's a rate. So dt is going to go on the bottom. What is the quantity for this guy? Yeah, so it's going to be inches, right? Right. And it's 3. Okay. It's 3 inches. Let me see. Let me double check 1 second. Let's see. Yep. So we write it shorthand. How do we write it shorthand? We write it shorthand like this. So instead of writing like that, we're going to say d inches, right? But instead of inches, we can say, what is inches? Inches is a measurement of what? What is inches? If he's growing at that, he or she is growing at that, it's going to be a measurement of what? Height, right? So essentially it's height. So what is changing? Height. So we can say dh dt equals. That means height. The top says height is changing over time. We know that's equal to 3 inches per year. That's how we would label it. Okay. My stock portfolios. My stock portfolios is losing 5 cents per day. My stock portfolio, each stock is losing 5 cents per day. Okay. So again, what is the rate? I'm not worried about what the number is. I'm worried about what is the quantity. Yeah, it could be value, or it could be portfolio, right? So you could say dp dt your portfolio over time is losing 5 cents per day. So if I wrote it like this, is that right? Why not? It's 5 cents per day. Okay. There you go. We got to put a negative there. Yep. Why didn't we put negative for 3? It's growing, yeah. It's growing. There you go, right? Because there's positive rates and there's negative rates. If you're losing something per day, like car values, if you have a car, as we speak, it's losing value, going downhill. Unless it's a rare car, which only a couple people have in the world, it's losing rate. It's losing value. It doesn't matter if it's a Ferrari or if it's a Honda or Hyundai or Toyota. It's losing rate every second. It's you have it. Okay, that's why cars are not good investments. That would be a negative, right? Things that grow are things like real estate. Real estate grows in value. Real estate grows in value. So as we speak, real estate's going back up. Okay, maybe not as fast as we'd like, but it creeps up fast. Okay. Stocks are some things that every day they either go up or they go down. Over time, good stocks go up, but every day they're kind of volatile, right? So every day, you know, if a stock is averaging 5 cents per day losing, that's not a good stock. But if it loses 5 cents in a day, that's not that bad. Every stock goes down and up. Okay. The radius. Okay, so the radius of a circle. The radius of a circle. You have a circle. It's getting larger by 4 feet each hour. Okay. So we're going to start at d something over dt. What is that something going to be? Radius, right? dr. We could say r for short. You can put radius if you want, but r for short is getting larger, right? 4 feet per hour. The outside temperature is dropping by 5 degrees Fahrenheit per minute. Temperature is dropping, right? For temperature, we usually use capital T because lowercase t is for time. So temperature, we usually use capital T. Again, you can put the word temperature in there. It's not wrong. You can put it, but in mathematics, we usually like to use shorthand. Okay? Dropping. So again, it's going to be negative 5 degrees Fahrenheit per minute. Okay? So we're going to see a lot of those because those are rates. One of the things we're going to have to label or find are the rates. Well, what is a rate? A rate is what? When we're talking about rates, what are we talking about? Change over time, which is also there you go. Derivatives, right? All of those are correct, but also derivatives, right? We're talking about derivatives. So anytime they talk about a rate, they're talking about a derivative. Okay? So we're going to be dealing with some equations today. So before we get to the actual problems, I did a little bit of practice. So each of these are each formulas. First one is Pythagorean theorem. The second one's formula for area of a circle, right? You guys have seen them many times. We're going to take the derivative of them. But with respect to time. Okay? So let's find the derivative of A. What would it be? What would we start? So we have 3 terms, right? I got this guy, I got this guy, and I got this guy, right? So let's find the first term. What would the derivative of the first term be? 2a, but it's with respect to time. So how would we give, what tag would we give it? dA over dt. Good. We've done this before, but we've never done it with A's and B's and R's and letters like that, okay? B, 2b dB dt, right? Because we're taking the derivative of B with respect to time. And then C would be 2c dc dt with respect to time, right? Anything that's not time related gets a d something over dt, okay? How about this guy over here? How do we find derivative of this guy here? Hmm? So let's start on the left. Yeah, let's start on the left. We have two sides, right? Yeah, we'll get to that, but let's start with the left side. I got an A over there. What's the derivative of capital A? 1. So it would be 1, and then what? There you go. D capital A over dt. Right? You don't need that one if you don't want to write it. You could just write dA dt. So in other words, it's saying the rate at which area grows over time. A is just area. dA dt is the rate at which area either grows or decays over time. So now this side over here. How many terms do we have there? How do we, or in other words, how do we find the derivative of that? Are we going to use product rule? Because it's multiplication, right? I agree, it's multiplication. Do we have to use product rule? Why not? Pi is, what is pi? Is pi a variable? Yeah, is pi a variable though? No, right? It's a value. It's so long that we don't write it. We just write it as pi, right? So pi is actually a coefficient. Pi is not a letter. Pi is not a variable, right? So pi is actually the coefficient. So how would we find the derivative of this guy? Mm-hmm. What would it be? Mm-hmm. So it would be 2 pi r, take away a power, and then what would its tag be? Dr dt, because the only thing we found the derivative of was radius, r, right? So if I want to find the rate at which a circle is getting bigger or smaller, that's the formula I would use, because that's the formula for area of a circle, right? If I want to find out, what do we use Pythagorean theorem for? We probably haven't used it in years, but what do we use it for? Actually, you might have used it last year. What do we use Pythagorean theorem for? What would we? There's a couple different things we use it for. What's one thing we would use Pythagorean theorem for? What about right triangles? So if I need to find the side of a right triangle, or I want to find out how fast a side is growing or getting smaller, that's the formula I would use. Okay, just depends on what you're looking for. It tells me about the sides of a right triangle. It doesn't tell me anything about the angles of a right triangle. That's a different formula. That would be trig formulas. Okay. Okay, so these are the steps. These are the 6 steps we're going to use. These are the 6 steps we're going to use for every single problem we do. Sometimes we'll use all of them, sometimes we'll use some of them, but these are the steps. These are the process. Step 1, write what you're given. They'll always give you stuff. If it's a related rates question, it's pretty easy to tell because there's rates. It talks about rates or it gives you rates. Write what you're given. Write what you know. Write everything you know. And then what are you trying to find? What is the question asking? Write that down. Okay? And then you're going to write an equation that relates to it. That's where related rates comes in. That's why it's called related rates.
we're going to write an equation that relates to the variables we have so far, to the given. We're going to write an equation that relates to the given. Number 4, I don't think we're going to do today. Number 4, we're going to skip that step for today because the ones we have today, we don't use step 4. The ones we do tomorrow, we'll use step 4. Step 4 says make sure this equation contains rates that you are given or are trying to find. If not, you can use a second equation. We won't have to do that today. Number 5, differentiate. What does it mean by when I say differentiate? When it says differentiate, what does that mean? What is that telling you to do? Anytime you see the word differentiate, it's an action word. What is it telling you to do? There you go. Find the derivative with respect to time, just like we did. Plug in what you know, solve for what you don't know. Okay? If you keep it to those 5 or 6 steps, it's not that bad. It's really not that bad. Okay? Couple things to know, though. Couple things you're going to see. A couple of things you're going to see are, number 1, we talked about it, right? Sometimes rates are getting bigger, sometimes they're getting smaller. If they're getting bigger, they're positive. If they're getting smaller, make sure you include a negative in there. Okay? So if something's decreasing in size, you're going to choose a negative. Sometimes you use the product rule. Sometimes you will use the product rule. Okay? So just be careful with that. Sometimes you'll use the product rule. All differentiation. Every time you do step number 5, it's always going to be implicit. What is implicit differentiation? When we do what? When variables are mixed together, right? Just like this guy right here. We had A's and B's and C's and A's and R's, right? So everything is with respect to time. So it's going to be, they're going to be given tags. D something over dt, D something over dt, okay? Don't forget about units if you're asked. If you're asked about units, don't forget about units like we did at the very top, right? We did units. So if you're asked to give units, make sure you do. If you're not asked, you don't have to include units. Don't plug in numbers into the original equation for things that are not constant. So don't, so if something is constant, what is its rate? 0, yeah, 0. So sometimes they're going to say something grows at a constant rate. Well, it's 0, right? 0 is a constant rate. It doesn't grow, right? If it doesn't grow, it doesn't have, it's 0, okay? All right, so let's look at an example. First example, first actual related rates example. Most of the time, it's going to be about a shape. Today, we're going to do 2 dimensions. Tomorrow, we'll do 3-dimension shapes. Okay, so 2-dimension shapes, squares, rectangles, circles, triangles, things like that. Okay, so this one's a rectangle. A rectangle has a length of 1 inch and a width of 6 inches. That's what the triangle or the rectangle has right now. Whose sides are changing? So they're changing as we speak. I didn't put this as one of the steps, but I always draw a little picture because it helps me see. Okay? Any length that goes horizontally, I call X. Any length vertically, I call Y. Just because I keep it simple like that. So the length of the rectangle is 1 inch and the width is 6 inches. So this is not to scale. It's not to scale, but at least it gives me a little picture. If I wanted to draw it to scale, I could change it, but for right now, that's good. Okay? But their sides are changing. As we speak, they're changing. Okay? The length is increasing by 4 inches per second. So this length down here is getting bigger. It's increasing by 4 inches every second. The width is also growing at 8 inches per second. How fast is the rate of the area growing, right? Well, if your length is getting wider, if your length is getting bigger and your width is getting bigger, what's going to happen to the area? It's going to be getting bigger too, right? Okay. Just how much? That's what it's saying. What rate? At what rate? Okay. So let's write down what we know. What do we know about the triangle or the rectangle right now? What's everything that we know? So we know the length is 1 inch, right? So this is step 1. Write down everything we know. We know that the width is 6 inches. Okay. What else do we know? We know a couple other things. They tell us a couple other pieces of information. What other pieces of information do they tell us? So they told us length is 1, width is 6. What else did they tell us? Length is increasing by 4 inches per second. That's a rate, right? That's a rate, 4 inches per second. How do we write that rate? How do we label that rate? Not dl over dt, because what did we use for length? We used, what letter did I use for length? X, yeah, we use an X. So, yeah. So if you use L and H, go for it. But since I used X, I'm going to use it X. So dx over dt is 4 inches per second. There's one other piece of information. What else do I know? dy over dt, good. dy over dt is 8 inches per second, right? That's what I know. That's every piece of information that I know. That's step 1. Step 2, what do I want to know? What do I need to know? So how do I write that? I don't have a number for that, right? I don't have a number for that. So I'm going to have a question mark there. But how do I label what I'm looking for? There you go. That's what I'm looking for, right? That's what I'm looking for. If I know that guy, I'm good. I've solved the problem. Okay. So now that's step 1 and step 2. We've done step 1 and step 2. Step 3 says write an equation that relates what you have with what you need to have. So what do I need to have? I need to have dA over dt. What equation would give me that using the stuff that I already have? So I have length and width, right? And I need to know about area. So which formula or which equation would give me that? There you go, right? So the formula that's going to give me that guy over there, dA over dt, is the area. Because just like Srishti said, the next step, what's the next step after this? We're not going to use step 4 today. The next step is differentiate. When I differentiate that, am I going to get dA dt, right? And don't I know everything except x and y? Or sorry, I know x and y. I know everything except a, right? And I can find a, right? So that's the next step. So the next step is differentiate. dA over dt equals x times y. For x times y, I have to use product rule. Okay? So the first times the derivative of the second plus the second times the derivative of the first. dA dt I don't know. Do I know x? Do I know dy over dt? Do I know y? Do I know dx over dt? So if I plug everything in, I can solve for what I don't know, which is step 6. Plug in and solve for what you don't know. Okay. X, we said, was 1 times dy dt, which is 8, plus y is 6, dx dt is 4. So we have 8 plus 24 dA dt equals, what is that, 32? Okay, 32. So let's go write it up here. It doesn't say the label. It doesn't say the label, but it's always good to label if you can. So what is 32 going to be? Okay, so inches per second. There you go. Yeah, I was waiting for someone. Squared, right? Because area is always squared. Area is always squared. Area squared, volumes cubed, side lengths are just nothing. Right, yeah. There you go. Okay. I went very, very slow on that one. Okay, because it's important. The slower you go early on, the easier it becomes. So if I'm going too slow for you, you're like, I got this, then don't wait for me. Go. Okay? Don't wait for me on the next one. You're like, oh, I got this. Do it. And then if you get stuck, then you can pick your head up. Okay? Because I think some of you guys are catching on pretty quick. If you're not there yet, it's okay. It's okay. It takes a little bit of time. Okay? So let's do example number 4 now. Example number 4. So now we got a right triangle. I got a right triangle. A right triangle, again, you don't need to draw a picture, but I always draw a picture just because it kind of helps me visualize this stuff. So a right triangle has legs of 33 and 44. Again, anything horizontal, I call X. Anything vertical, I call Y. So X, let's say in X, one is 33, one is 44. It doesn't matter which one's which. Doesn't say which one's which, so I'll call this one 44 and I'll call this one 33. Okay. Whose sides are changing? Okay. The short leg is increasing by 4 inches per second, and the longer leg is shrinking by 10 inches per second. What is the rate of change of the hypotenuse? So what is the hypotenuse? It's a big word. What does that hypotenuse mean? It's always opposite of the right angle, right? Always opposite of the right angle. So we'll call that, since that one's kind of going sideways, it's kind of diagonal, we'll call that Z. We'll call that Z. Most of the time, you guys use probably A, B, and C. But the reason I'm using X, Y is because I want to remain constant throughout all of these problems. I don't want to use L and H and A and B. I don't want to use different letters. It's always easy to remain constant. Okay? Okay, so first step, what do I know? I know that the side length, I know X is 44 inches, right? I know Y is 33 inches. I know the short leg. Well, my short leg is Y. So that would be dy dt. I know my short leg is Y, so dy dt is increasing by 4 inches per second. So I'm going to give that one a 4. And then the long leg, which is my X, is shrinking at 10 inches per second. So that's going to be a negative 10. I'm not labeling yet. I'll label at the end. Inches per second. I'll label at the end. Okay? I'll label units at the end, I should say. What is the rate of change of the hypotenuse? So how would I label that? dz, yeah, dz over dt equals question mark. That's what I want to know, right? I want to know the rate at which z is getting bigger or smaller. So what is an equation that would relate all of those different things that I know? and give me hypotenuse, length. Pythagorean theorem, right? Pythagorean theorem. They're not asking us about area, so we don't need area. It's not asking us rate of change of area of the triangle. It's asking us the rate of change of the hypotenuse. So that's why we're going to use Pythagorean theorem. Okay? I use X and Y's and Z's because that's what I use. I want to stay consistent. I don't want to introduce other letters because then that gets more confusing. Okay. That's step 3. Step 4, or step 5, I should say, differentiate that guy. Okay. Oops. So it's going to be 2x. Yeah. 2x dx dt plus 2y dy dt equals 2z. Oh, sorry. Yep, no, that's right. dz dt. Okay. That was step 5. Step 6, plug in what we know. Okay. 2 is just 2. So 2 is going to stay 2. 2 times x, we know x is 44, times dx dt, we know that's negative 10. So all of those guys multiplied. 2 times y times dy dt. 2 times, do we know z? We don't know z. And I don't know dz dt. That's a problem because if I want to solve for what I don't know, I need to know everything except just one. So is there a way for me to find z or dz dt? Yeah, you can use Pythagorean theorem to find z. They didn't give us z, but we could find it, right? It would be 33 squared plus 44 squared equals z squared. This is probably, if they want you to do this, it will be a calculator question, because to do all of this without a calculator would kind of be difficult. So 1089 plus 44 squared, 1936 equals z squared. 3025 equals z squared. And I get 55. I guess you could do without a calculator because it's a 3, 4, 5 right triangle. Because if you divide all of them by 11, it's 3, 4, 5. I guess you could have done it with that. So z is 55 times what we don't know. Times what we don't know. Find what dz dt is. Find out what the missing part is. So I got negative 616 over 110. Is that what you guys got? If I did my arithmetic correctly. Okay, you can simplify that. I mean, you can divide it by 2. I think if I divide it by 2, something over 55, was it negative 301 or 308? If you get to that point, I'll give you full credit. It might be able to reduce again. I don't think it is, but if you get there, I'm good. Okay. Or if you don't, like if you give me negative 616 over 110, I may take off like a half a point. Nothing like crazy. Okay, for not reducing. I'm more concerned about everything before that. Okay. And actually, if you don't reduce, if you don't reduce is the only thing you don't do, I probably wouldn't take off any points, because that's not a calculus mistake you made. That's just a reducing mistake. Okay, so negative 308 over 55. What label would this get? This one would just be inches per second. Yeah. About 5 or 6, negative 5 or 6 inches per second, around there. 5 point something. Okay. All right. So the nice thing about related rates questions is they all follow along the same steps. They all follow along the same steps. But the hard part about related rates questions is they're probably the most word problem things we do. They're very word problem-y, right? So they're kind of like they're different than everything we've usually done. But like I said, if you stick to these steps, you'll be fine. So what I want you to do right now is do 5A. Do 5A and 5B if you want. We'll do 5B together, but if you want to do 5B, do it. Okay, 5A. Okay, so I think we'll have time for A. I don't know if we'll have time for B, but maybe we'll do it tomorrow. So it says a 25-foot ladder is leaning up against a vertical wall. Okay, so Y is the wall. Z on mine is I label it in blue as the ladder. Okay, the ladder is 25 feet. That, we know that 25 feet. The bottom of the ladder is being pulled away at a rate of 3 feet per second. The bottom of the ladder is right here. Right, the bottom of the ladder is right here. It's being pulled away. So it's going that way. This guy is going that way at a rate of 3 feet per second. Okay. How fast is the top of the ladder moving? Well, if this part is going this way, what is the top of the ladder going to be doing? It has to be going down, right? It has to be going down. Okay. So what do we know? Well, I know that the ladder is 25 feet. So that has to be 25 feet. I know X is 15 feet. All right. They don't tell me Y, but can I figure out what Y is? Yeah, it's a right triangle, right? And actually, if you divide them all by 5, it's a 3, 4, 5 right triangle. So this is actually going to be 20 feet. If you divide all the lengths by 5, you get 3, 4, 5. It's a 3, 4, 5 right triangle. Okay. Okay, so rates now. The bottom of the ladder is being pulled away at 3 feet per second. How do I label that? There you go, dx over dt. And is it positive 3 or negative 3? Yeah, why positive? It's moving this way, right? So if it's moving this way, x is getting bigger. dy dt that's what the question is asking, right? dy dt is what the question is asking. How fast is the top of the ladder? We know that's going to be a negative number. We know it's going to be a negative number when we get there, but we're not there yet. Okay? dz dt. Kind of a trick question. What is dz dt? Yes, why is dz dt 0? It's a ladder, yeah. The ladder's not getting bigger or smaller. It's a 25-foot ladder, right? So that's 0. So we actually know dz dt. Because it's a ladder, it has to be 0 because it's not growing or getting smaller. Okay? So we need to find dy dt. That's what we need to find, dy dt. Well, again, they're talking about side lengths. So we're going to use Pythagorean theorem. Well, I'm going to kind of cheat a little bit here. I did it before, right? So essentially you're going to do the same thing. You're going to do these steps here. That's my next 2 steps, right? Identify I'm going to use this guy and then use this guy. So I'm going to cheat here. I'm going to cut and paste. Okay. And then I'm going to plug it. So let's see. We know 2 times x. X is 15. Dx dt is 3 plus 2 times y, 20. Dy dt, we don't know. 2 times z times dz dt, which was 0, right? Now let's do some math here, some mental math here. 2 times 15 is 30 times 3 is 120? No, 90. This is going to be 40 dy dt. And this guy over here is just going to cancel and make 0 because it's 50 times 0. Subtract 90 from both sides. 40 dy dt equals negative 90. I'm going to move it over here so I run out of room. 40 dy dt equals negative 90. Divide by 40. Dy dt equals negative 9/4. When I reduce it, it's a negative 9/4. What units is that going to get? Feet per second. Yep. Done. Mm-hmm. You can do that. That'd be fine. Mm-hmm. You can change it to a decimal. Not required, but you can change it to a decimal. Especially if you can use a calculator. If it's a nice decimal, if it's a terminating decimal, that's always okay. Sometimes if you get into some things that are like non-terminating decimals, I would stay away from that. I'd keep them as fractions. But if it's a terminating decimal, that's always okay. All right, guys? All right, so tomorrow we'll finish. We'll do B at least. I'm not sure how far we get. Then we move into 3D, 3-dimensional shapes, which is the same idea, just different form.